Thank you, guys. I think everyone had a nice tea break. I had a wonderful set of keynote speakers previously, so it's a tough act to follow, but we'll try. A couple of words about myself and Greg. As the presenter just said, I spent the last 6 years working as an OpenShift specialist covering US Navy and US Marine Corps, which I think is very much relevant for this discussion. We're going to be talking about mobility. So US fleet is very mobile. There are 470 ships that the US has, and at any given point of time, they're out there. Most of them probably heading for service. But and then there's a ton of data management issues that come up because a lot of environments are disconnected. A lot of them are in low connectivity type of environments or air-gapped. There are a whole bunch of security that needs to be taken into account. So all of those things are very, very relevant to what we're going to be talking about today. Greg?
Thanks, Cheslav. So my name is Greg Schultz. I'm from Portworx. And for those of you that are unfamiliar with Portworx, it's part of Pure Storage. Pure Storage acquired Portworx about 5 years ago and created the Cloud Native business unit, which I'm part of. So pretty much everything related to Cloud Native, I'm across the Pure Storage business in Australia and New Zealand. And Portworx has been part of the Cloud Native ecosystem for the last decade, really, since the unveiling of Kubernetes about 10 years ago. And for the last 20 years, believe it or not, I've been in the infrastructure space and with a specialization in data management solutions. So today, Cheslav and I are going to be talking about hybrid workload mobility and data management across the cloud. Now, there's a lot of words to describe what we're going to be talking about, but it's intentional. And we wanted to really highlight the contradiction, really, amongst those words. And what is the contradiction? When you talk about workload mobility and data, these things typically don't go very well together. Why is that? Well, data has got this gravitational pull on a workload, and it tends to become an anchor for your workloads and anchors it to one location or the other. And really that's come about through a mismanagement in the technology ecosystem around data storage technology and the lack of open standards for the variety of data storage technologies that exist out there today. So what we're hoping to do is to share how using Kubernetes with a container-native data management solution can really unlock these stateful workloads and help organizations to accelerate their transformational projects to containerization. So just quickly, a quick intro into what hybrid workload mobility is. It's really about taking your workloads, applications, data, computing resources, and moving them between different infrastructure types. And why is that important? Well, it allows organizations to really gain the benefits of each of the different infrastructure types and managed service providers that are out there today. And some of those benefits include cost optimization, so taking a workload and moving it to the most cost-efficient infrastructure and really reducing that operational expenditure over the life of that workload. Performance. This is it's a big topic, but one aspect to it is, we think about, reduced response times, high throughput. You think of the age of AI, you need to move your workloads to where you've got GPUs, and everyone knows that there's a scarcity of those things around today. Security, another big topic. One aspect to that is data sovereignty, right? We know in different regions there is authorities that impose rules around where your data needs to reside. And if you might have sensitive data, that's going to reside on your private infrastructure, and you might have less sensitive data that's going to reside in maybe the public cloud. Scalability. one of the things you might have heard of in the past is around cloud bursting. If you've saturated your infrastructure on premise, there's a lot of capability out there in the public cloud to be able to expand your environments and use those infrastructure services. And then business continuity, having the ability to move workloads between independent infrastructure providers, it opens up a lot of options for organizations to meet the governance requirements, once again, within the bounds of the authority in the region that they reside. So I put this quote into the slides because I actually really like it, and it comes from the Boston Consulting Group, and they did some research around platforms, computing platforms. And this really reinforces what we are trying to talk about today around hybrid workload mobility. And I'm going to read the quote. When an organization has the right platform, one designed for agility and portability, they can better respond to change and outperform their peers by 4.5x shareholder return. When an organization has the right platform, and it's really about the platform. And if we think about it today, the leading technology to build a platform for agility and portability is containers and Kubernetes. So I'm going to hand over to Cheslav, who's going to talk a bit about a modern computing platform.
Thank you, Greg. So we're going to unpack for a few minutes what it means to be agile and portable. So what is really agility? Well, typically, I like to simplify those terms as much as I can. And it's really about ability to respond to change quickly, right? And so that could be anything. It could be launching a new service. That could be responding to a particular customer demand or request. That could be scaling up or down. And so that all of that has to do with how quickly you can respond to those requests. And an ability to do that is essential. Now, portability is quite simply you can think of it as a freedom of movement. So if you've got your workload, you should not ever have that tied into any particular environment. You should be able to run it on-prem. You should be able to run it in the cloud, in a hybrid environment. So never one particular provider, never one particular environment. So those are kind of the simplifications of those terms. Now, what makes that possible? I think Greg has alluded to kind of the unit measure of both, which is really containers. So you take, I think all of us, or at least majority of us, know what the containers are. You package the application with everything that's needed to run, and then they behave in the same way wherever they end up running or wherever they land. So once you've got containers, then you move into kind of the next stage. You need to have a framework for managing those containers. And Kubernetes is that platform that orchestrates containers. And it automates how they deploy, it automates how they scale, it automates how they, you manage them, and you manage the applications that run within it. So I think if you look at the Kubernetes and other things that I list out here, I'm not necessarily going to go through all of them, but the point here is that you see Kubernetes and the sort of container orchestration is really the foundation of how all of the modern platforms are being built. So, but what do we want to run on those platforms? Do we want to just create a container, throw it into the orchestration engine, and let it run? Well, maybe not. I mean, especially not in a case when what we're actually trying to do, we're trying to run enterprise-grade workloads, as opposed to just sort of any workload. So how do you define the enterprise-grade workload? Or what are the criteria for them? Well, I think the criteria for enterprise-grade is performance, it's reliability, and an ability to scale, whether up or down. And then when you start uncoupling that, you start seeing that the components that come together in order to create or to support the enterprise-grade workload really land on either compute, networking, and storage altogether. So compute, the processing power behind the workloads that are being run. It's within the Kubernetes typically represented by pods or the nodes that they run on top of, but you would see more nuance. You have to deal with things like taints. You have to deal with things like tolerations and affinities when you really want to run your workloads in a way where you can get measurable results. Now, networking is very important as well. Majority of the kind of cloud-native workloads that end up being run on Kubernetes are following the microservices architecture. So when you take the microservices architecture, you really start decoupling things kind of from a monolith into multiple services. So the communication between the services, not just the communication, but also a predictable and secure communication becomes extremely important. And so in some ways, you can think about taking the complexity out of the monolith and pushing it out to the network, right? The network between the services. So when it comes to enterprise-grade type of workload, you not only just need to take care of straight-up connectivity between them, but you want to do it in a secure way, in a predictable way. You want to support multi-networking. You want to support different load balancing policies and all of the different additional components within the Kubernetes that come to play in order to handle that type of workload. Storage the same way. Enterprise works required persistent data needs, and then for that you have other classes within the Kubernetes framework. So all of that to say, it's not necessarily to run through various components required. I mean, it's clearly there are quite a lot of them. But the point always is that you want to configure and run them in a Kubernetes way so that you achieve this performance, scalability, and security. So if Kubernetes is really foundational to running an enterprise-grade workload, then the question comes up, is that enough, right? I mean, is it enough to just simply have Kubernetes out there? And it is very powerful. There is no question about that. But I would argue that when you start building on top of that, you get a much greater impact. And so a tool like OpenShift, which builds and enhances Kubernetes, and in fact, this pictorial indicates that we use Kubernetes as really a foundational piece, right? I mean, it's an engine that drives the rest of the components that thrive on top of that. But the rest of the components are extremely important. So you get all of the integrated DevOps services that are now improving both the developer productivity as well as the ability to put the workloads into production. So things like CI/CD support, the serverless, the DevOps, right? All of those things are integrated in an OpenShift, which of course builds on top of Kubernetes. Then you continue to add to it, with security features, ability to run and scan your containers and or virtual machines that can be housed together under the same platform. Advanced management features, integrate web consoles, integrate observability layer. All of that comes to play, as well as more and more services. Things like event-driven automation, right? I mean, all of that integrates together, and one would argue that it's almost necessary if you need to drive from the foundational engine of Kubernetes toward this complete cloud-native application development platform. Greg?
Thanks, Cheslav. So I think if anyone in the room has spent any bit of time with Kubernetes, I'm sure you'd all agree that it solves the application orchestration problem pretty well. In my mind, it's brilliant because it does this without a lot of human intervention, and that really allows us to get to some really significant scale with these platforms. But when we look at it through an enterprise lens, there's other things that we need to consider. This is just the tip of the iceberg, right? And when we look at an enterprise, and we look at the enterprise estate, application estate, roughly 60 to 70% of that estate is stateful. And what do I mean by stateful? It might be a new term for some in the room. And these are things like databases, message queues, search platforms, AI workloads. All of these need data, and they need an associated data storage platform. What a lot of people don't realize is that when Kubernetes was architected, it was never architected with data orchestration in mind. It was architected specifically for stateless workloads. So this does tend to become a blocker for organizations looking to bring stateful workloads into Kubernetes. So these are some of the challenges that organizations need to face. And the type of things that organizations need to consider in the enterprise are all you can see at the base of this iceberg. You know, highly available storage, business continuity, data encryption, backup and recovery, automated capacity management. So these are all things that are table stakes for a traditional style application and are very familiar to most enterprises. Now, how do we do this in Kubernetes? In my mind, the best way to do this is with a software-defined approach, right? And it's proven, right? So if you think about compute abstraction, if you think about network abstraction, it's all done in software, right? So we really should be looking at data and the data storage lifecycle from a software-defined perspective. And this is where Portworx comes in. But the key is to be able to provide all of these things at the base of the iceberg without breaking one of the key tenets of Kubernetes. And what is that? That's hybrid infrastructure abstraction. So this is the value of Portworx. It's going to provide all these capabilities without being tied to any particular hardware. And it's going to help organizations to really accelerate their containerization business case and transformational projects. All right, so what does this actually look like? I've got a couple of slides here with some visualizations. Hopefully they do work. On the left-hand side, we've got a Kubernetes cluster, and we've got 3 stateful workloads there. We've got a Postgres database, a Mongo database, and a MySQL. All 3 of these are consuming persistent volumes from the worker nodes, the Kubernetes worker nodes, and this is being provided by Portworx. Now, Portworx is deployed as software, right? It runs within the Kubernetes worker nodes or the OpenShift worker nodes. And you'll notice here that I haven't depicted any of the hardware infrastructure underneath, because Portworx is completely infrastructure agnostic, right? Much like Kubernetes is completely infrastructure agnostic to the compute. So we have a second cluster. It's also deployed with Portworx. And the first thing we do is we set up a cluster pair, right? And this cluster pair is actually represented in the cluster by a custom resource. And it defines how these 2 environments talk to each other securely and how they share information securely. The other aspect that we need to configure is a common object store. And this is going to be that transition zone for moving the data. So once we have these things set up, we activate a migration schedule, and it's going to do 2 things. It's going to start working on the Kubernetes resources that underpin those workloads and stage them in the second cluster. It'll then also start working on the persistent volumes and all the data that's contained within those entities and stage it. And you'll notice there's a yellow box on the right-hand side. And what we're doing is we're actually keeping those pods scaled to 0. So essentially, we're staging the entire environment at cluster 2, and we can remain like that for as long as you want. When we're ready to cut over, we simply scale down the workloads in cluster 1, we pause replication, and we scale up the workloads in cluster 2. Now that literally takes the time to spin up a pod, right? So that's how we do, very simply, a one-to-one cluster workload migration. What happens if we want to do one-to-many, right? So we can see how we've done a one-to-one. Here we've got a green namespace, and with a cluster pair and Portworx, we can move those workloads across to cluster 2. what happens if we have another business unit using a different namespace, a red namespace, and they want to move that workload to a third cluster, totally different cloud provider, different infrastructure underpinning that. We follow the same process. We create that cluster pair that defines that secure communication on how we're going to share information between the entities, and we activate the migration schedule. So that's a very quick, high-level overview of how we do hybrid workload mobility. If you want to know more, please come and have a chat afterwards with myself and Cheslav, and we're happy to share some more. I'll hand over to Cheslav just to close us out.
No, I think that we stayed almost on time, I think. I think we're
pretty close.
Less than 1 minute out. But I think what we touched upon are some of the relatively deep concepts. So any one of those blocks, I mean, you can spend probably an hour or two discussing, so we're more than happy to stay on and have more in-depth, deeper discussions about any of those components. And thank you very much for your time and for your attention.
Thank you.